All right, welcome. This is session number 5, and it has a title, Technology Deep Dive, Transformative Technologies that will reshape the critical minerals industry. My name is Donald Sadoway, Professor Emeritus at MIT, and I'm really pleased to present this fantastic panel of 6 specialists. The breadth here is really uncommon. What you've heard before today is very narrow, monochromatic. This is in full color. These people are very knowledgeable. So the format of this is each speaker will have 3 minutes to say whatever they want. They will announce who their names are, and so, of course, but then they have 3 minutes. And if they go over 3 minutes, then I will stand and look sternly at them to humiliate them. So I know they're going to finish. And then, after everybody's had a chance to speak, then I will ask for interactions between the members of the panel. So, as I said, this is very wide-ranging. We have tough tech, and then we have software, control, analytics. So you have the whole spectrum. So please enjoy this. I hope you enjoy it as much as I know I will. Okay, let's get started with Katase-san.
Thank you, Don. My name is Hirofumi Katase. I'm with a company called iPulse. This is a US-based company, but with a technology based in France, Toulouse, France. And I would like to speak about what this company is doing and how, because this sort of epitomizes the theme of the today's panel. So iPulse is a very unique company which sort of develop application based on core technology called the incurrent pulse. So please think of the battery. So there is 1 kilojoule of energy. But if you sort of shorten the time of the discharge to like 1 millionth of a second, you can discharge 1 gigawatt of power, just only 1 millionth of a second. And we can literally change the way the minings are conducted by using this principle. Let me cite some examples. The first on exploration. We have developed IP generator or electromagnetic generator, which you can do a survey, geophysical survey up to 1.5 or even 2 kilometers deep, which is 4 times the conventional technology can do. And it was instrumental in finding oitologoi mines in Mongolia. And also we are formulating the joint venture with Ma'aden, national mining company of Saudi Arabia, 50-50 joint venture. And by the way, you can see this typhoon system after the exit of the hole. So please do not forget to see it. And second application we are doing is to the production enhancement of the wells from oil well to geothermal well. So the idea is you insert the tool and you discharge the shock wave, and you can remove all the scales without any chemical intervention, and it literally renew the production of the well. So these are already commercialized, and what we are now doing is rock crushing of the rocks. As you know, rock crushing is taking the 4% of the global power consumption in the world. But by using this pulse technology, theoretically we can reduce the power consumption by a factor of 80%, 80%. So we are now teaming up with BHP and Bill Gates Foundation to develop this tool. And last but not least, we are developing the drilling technology, which will drill the very hard rock with more than 50% cost reduction. So we are using the combination of pulse power and the conventional drilling. So these are just the example of what we're doing. And one interesting is that the way we are trying to commercialize is to do it by ourselves, not provide our services. So this will speed up the speed of the bringing the new technology to the market. Thank you.
Excellent. Next, Emilie.
Okay. Hello, everyone. My name is Emilie Bodoin, and I'm the founder and CEO of Pure Lithium Corporation. We're a Boston-based company, and we make, guess what? Pure lithium, and we put it in batteries. So our technology takes dilute sources of lithium. So imagine an oil field brine right here in the Kingdom of Saudi Arabia that contains lithium, and we put it in a bath, and we make it into a battery-ready component called an anode in one step. This eliminates a tremendous amount of complications through a supply chain and processing and saves a lot of energy. By going directly from brine to a component, we then didn't stop there. We make a battery. So we make a lithium metal battery that has a vanadium-based cathode, and this is a next generation battery well beyond lithium ion. We're replacing the graphite in your battery that you have now with pure lithium metal. I'm excited to be here today at this really fantastic event. It's my second year here, and I'm excited because of the opportunities in the kingdom that has both vanadium and lithium. So for pure lithium to go directly from brine to battery here and develop localized supply chains, that's our goal. And I think that this is, one of the most impactful ways to sort out supply chains and introduce new technologies to the market is try to localize them. Finish early.
Yeah, okay. So hello everyone. This is Saeed Al-Shehri, the VP for Energy and Industry Sector at King Abdulaziz City for Science and Technology. So King Abdulaziz City for Science and Technologies has two functions. The National Lab, where we focus on applied research, industry-oriented research, and also the provide technical advice to the government. On the other side is the Science Park, where we try to create innovation hub in the company, in the kingdom, actually open our campus actually to all the key players in innovation ecosystem, big companies, deep tech, scientists, VCs. So, and of course we have the garage, I think the largest incubator and accelerators in the region, with more than 150 companies from 45 countries. So when it comes to mining, actually, KAICC, we focus on all the value chain from exploration. We are trying to inject digital-related technologies, actually, to enhance the level of confidence, integrate the remote sensing with the AI and other technologies, and also the advanced analytics and other digital-related technologies to get better decision-making and also optimized allocated or mineral resources allocation. So and also on the other part, actually on the downstream, we are working on advanced material, and we are working with different entities, international, national. Ma'adin, for example, we have a joint center with Ma'adin to work on the mineral processing. As you know, this is one of the challenges that the world faces, the mineral processing. So we are working with them actually on different metal alloys. And as you can see today, it's been announced by the Minister of Industry and Mineral Resources, the MIAB, the Mineral Innovation and Acceleration Park. It will be located at KAICC, and it will serve the mining sectors and also the super region. It will be the innovation hub for R&D that cover the value chain of mining. And again, we integrate the material labs with the mining 4.0 technologies, with the AI and other emerging technologies. So this is in partnership with the Ministry of Industry and Ma'adin, Saudi Geological Survey, and of course NIDLib to fund this initiative. So this is quite brief about KAICC and about the mining activities at KAICC. And I think I'm okay now with the 2 minutes.
Yeah, you're okay. You're okay.
Done well. Thank you, Sayed. So I'm Sarah Coleman. I'm the president of Idoba, which is a digital transformation business, part of the Parenti Group with investment from Sumitomo as well. I guess when we look at transformative technologies, a lot of the focus that we're looking at is on digital and how we leverage AI. And particularly as we start to transition operations from traditionally being focused on cost and volume and a little bit around quality, and a lot of our systems and processes and digital systems have been set up to look at how we optimise an operation for cost and volume. As we start to move into a world where ESG becomes so much more important, the levers for optimisation in an organisation increase substantially. So we go from optimising a business on cost, volume, quality, to cost, volume, quality, energy, emissions, water, social. And those levers for optimisation really do start to become too great for the human mind alone to be able to comprehend. So a lot of the work we're doing from a digital perspective is to start to look at how do we actually provide decision support to the humans actually doing the work, and how do we ensure that all the information we have is actually integrated, intelligent, but importantly it's distributed to the right decision makers. And I think in order to do that, we have to have a high level of accuracy in the way that we're actually doing the digital work. And if we think about a lot of the traditional digital tools that we've had in mining, a lot of them have actually been based on almost rule-based engineering. So we think about some of our traditional simulation technologies, we'll put the inputs in and the constraints we believe might need to be there. So if we look at optimising a mine, we might say, well, we expect to have this amount of queuing, or we expect to have this amount of congestion. Now, the problem with that is it's actually automatically introducing bias from our own experience. What we're seeing is the ability to start using things like neural networks and neural-based decision-making, where we can actually leverage AI and neural-based AI to actually start picking the patterns of behaviour and allowing that to actually determine what the outcomes are, rather than putting artificial biases in through what the human minds believe. And with that, we're starting to see really high levels of accuracy in being able to model and map what's actually happening in the operations. So for instance, one of our products that we've currently got in 12 operations, we have 60 algorithms running across each of those operations, and it's learning and relearning every 7 days to actually understand what are the behaviours, what are the decisions that are actually being made, and how do we actually model and map that to be able to predict the future to a much higher level of accuracy. A lot of the tools in the past have really looked at, we take the data off the equipment and we try to optimise for the equipment, but the human element is actually where a lot of the uncertainty and a lot of the variability come into it. So now we're finding ways to be able to model and map that variability that comes from the behaviours. And so we're seeing that as being a really huge opportunity in terms of how we drive that decision making and how we drive that digital decision making. And with that, I think we'll start to see over the next 5 to 10 years the ability to integrate a lot of technologies that already exist, but how do we actually start to bring them in, and how do we start to add in this behavioural and neural-based element of it, so that we can rely and trust on these digital systems to be able to make the decisions with a high level of accuracy. And so that's where we see a lot of the future moving towards from a digital perspective.
Thank you, Sarah. My name Oliver Beck. I am with Inomotics. Inomotics is a Siemens company based in Germany, and we are delivering electrification solutions into the mining industry since more than 100 years. But I would like to touch actually a little bit more on what you just said, Sarah, regarding what from our perspective is the technology that is currently really transforming the mining industry, and that's for us as well, the digitalization, so software. And what we see since, I would say, 5 to 10 years, that software and digitalization have matured to a level that really generates and exploits a lot of benefits for mining customers. Both from the greenfield side, so whenever there's a greenfield project, we have a lot of possibilities to, for example, shorten project delivery time, project lead times, engineering time, and so on, but also on brownfield mining operations, and especially there, where we are touching with a lot of different possible tools. One of them you mentioned, for example, AI-assisted decision-making for operators, things like that, or also tools where we are looking into the process and trying to optimize the process with a target to increase the productivity, with a target to increase safety, and with the target to increase energy efficiency. And at the same time also, I mean, every mining operation is also very connected with a lot of risks at the same time to reduce risks. And there, from the different software and digital portfolio elements we are having, I very much like to touch on one of them, and that's a digital twin of a crushing and conveying system. And one of our customers, Collahuasi mine in Chile, one of the biggest copper mines in the world, they had an issue with their conveying and crushing system, that they could not deliver the throughput amount, the productivity that crushing and conveying system was actually designed for. And so they approached us, our experts got together, and we created a digital twin of that crushing and conveying system. So with all the properties, all the characteristics of that system, and we could identify actually where the bottlenecks are, where the issues were that they could not reach their production capacity in that system. We identified them. We could also in this 3D, in the virtual model, in this digital twin, we could also check which remedy actions are working, what needs to be done to make that, increase that production capacity, and then we implemented them into the real system. Yeah, and for me, very important, not by increasing power, not by making any changes to the mechanical part of that system, but just by the way of how you operate it. And this really gave several percentage points of productivity increase for the complete Collahuasi mine. And this is, for me, really technology today that we have at our fingertips that can make this transformation possible.
Thank you, Dr. Sadaway. Assalamu alaikum and good afternoon, everyone. First, I'd like to thank both the Ministry of Industry and Mineral Resources and the Future Mining Forum for putting on this amazing event. I'm truly honored to be here with these esteemed panelists. My name is Yamin Al-Hajjar, and I run a Boston-based venture firm called Olive Tree Capital. For the past 10 years, we've invested in life science companies as well as companies in the frontier technology space. Where that applies to mining specifically is we've backed several companies that we believe have the most potential globally to have significant impact in mining. One specific example is a company called Phoenix Tailings that you're going to hear from tomorrow. And Phoenix Tailings refines mining waste, and so every traditional mine has a large tailings pond or tailings site that often gathers tons of refuse. And what Phoenix has been able to do is develop a proprietary technology to clean up those mining sites. But as well, it's become the fastest growing critical minerals company in the world at this point. And as we look at these investments in a broader scope, it's very important to back very ambitious, very capable technical founders. But I think one key aspect is beyond developing science in the lab, the growth, scaling, and commercialization aspect in a sustainable manner as you expand these projects, whichever business model you decide to pursue, how that can have a larger impact on a global scale. I think one other area is everyone's talking about ESG and more conscious mining. There definitely is a transition period because many people want these resources and these methods to be implemented now. But there will be that transition period, and it's important to develop very stable business models with good profitable businesses and good margins to be able to make that transition more smooth. I think another aspect, and something we've been honestly very impressed with, so I am Saudi and obviously I grew up in the region, I've studied abroad, and we've been investing globally. But it's very refreshing to see on the ground the type of reception that the companies, and I think many of you have already felt this, in excitement and the level of coordination between both the public and private sector in wanting to enable the very best to come and develop this super region, specifically on critical minerals. And so Saudi Arabia, our history is obviously very well known in one specific resource, oil, but the potential in all the other industries adjacent to that, with mining as a core one, and how that can transcend today into a national champion like Sear Technologies trying to build an electric vehicle in Saudi, but there's many adjacent spaces that can come together. And I think even first-time visitors will sense this energy in the air. We've witnessed it firsthand, and so we had several meetings with leaders in both the public and private sector. And again, as someone who's kind of transcended both worlds, spent a significant time abroad and come back, it was very refreshing to see, a regulator refer us to a private sector player, to then refer us to one of the ministers, and then to another government body, all of which are very much motivated to replicate whatever success and really bring that technology in a structured and scalable way on the ground here in Saudi, to the extent that many players and many of the companies around you have many options around the world. There's many very strong areas to pursue mining. Others have certain deposits or different tax breaks and programs, whether that's in parts of Africa, Australia, around the world. But I've noticed this, and my colleagues have come back and said, we may actually want to redirect or re-strategize how we think. We will continue to do our work and grow and expand our technology or expand our platform, but Saudi seems like it's a very viable option to come because of that level of coordination and welcoming, which, again, I am a fairly outside party to witness, but very refreshing to see. And thank you again for allowing us to speak here, and back to you, Professor.
Thank you. Okay, so we've gone through the entire range. I hope you've appreciated the breadth of the approaches to transformative technology. So these are 6 intelligent people here, and I want to give each of you the opportunity to make comments on what you've heard. So please, we have some time. I'm looking at my timekeeper. When he gives me a gesture, then I'm going to cut you off in mid-sentence. So please, who would like to make a comment? Emily.
Yes. So I have a quick question for Katasi-san here. What potential use could your technology be for battery production? Perhaps cases or?
You mean the time to production? Well, for the 2 technologies, this geophysical survey and the production estimate is already in the market. For the drilling, I think we'll be able to bring it to the market in 4 years from now. Yeah.
That's fantastic. It's really impressive, the breadth of what your one technology is able to do.
Yeah.
Really interesting.
Thank you.
Anybody else?
Any other questions?
Everybody shy? Do you want to go to the audience? Do you have a microphone? Yes. Okay. If you change your mind, just make a gesture. But in the meantime, anybody in the audience would like to ask a question of these people? Raise hand. We will come with microphone. Oh, there's a hand.
So you all have been obviously very, very successful in scaling up these innovative technologies. Can you tell a little bit of the story about your first customer adoption, or your first customer adoption, or the first time you really established that product market fit, and how did you demonstrate that to investors, to shareholders, et cetera?
Who wants to take that one?
Do you want to?
It was very hard to hear. Is it possible to repeat the question?
Yeah.
Sorry.
He's talking about how do you demonstrate that you're ready for first-time investors, you've got first-time new technology. How do you get over that barrier where they're basically doubting, and you have to prove that you've got this technology
Yes,
that's turnkey,
thank you.
Yeah,
Thank
yeah.
you.
but you can't get the turnkey until you get the investment. So how do you break through the wall?
Yes, well, we broke through the wall. Thank you, Don. Your hearing's great. We broke through the wall during COVID, and it was tricky. I think the most important thing is having a solid business plan, having somebody with a commercial brain from day one, because it will eliminate a lot of mistakes and different paths, and making sure that you have an economically feasible plan, even when you're early stage. Because if you don't have a business, and then therefore you don't need an investor, and you should just go get a grant and play around in your lab. So if you tick off those 3 boxes, and it makes sense, and you can justify it, then you need data. You need small amounts of data, and it doesn't matter if you have a little data as long as it has high integrity and you have experts behind you, and then you're off to a running start. But if you don't look closely in the very beginning, I think that's when people can really run into trouble.
Sarah,
I was going to say, I think expanding on that as well is it's about. I see a lot of technologies out there that are a solution looking for a problem. So I think one of the really key things is also making sure that it's a solid business plan, but actually making sure you're understanding who is your audience, who are you actually selling to, and what is the problem that you're actually solving. And actually really making sure you understand the human element of it as well. There's a lot of great technologies out there, but everybody wants to transform, but nobody wants to change. So how do you also make sure that you get that balance between understanding that you have a solution that is solving a problem, and that you actually understand how to take people on the journey as well. And I think it's really important, the operations, to make sure that you really nail those elements early as well, and that makes it a lot easier.
Another question up here. Oh, there's more, but I saw this hand first. I'm sorry, that was the way it worked. Look at all these hands. What's the microphone? This one here. I have to make a decision, and it's cruel, I know.
Not a problem. I hope everyone can hear me. We supply staff to the mining industry globally, and one thing that's come up at a number of these conferences is Mining 4.0. One thing that we're not seeing is companies investing in actually training and developing their staff for the 4.0 transition. What are you panelists proposing companies should be doing to ready the future generation? Because there's already universities already showing that people aren't interested in mining anymore. They want to do tech. They want to become social media influencers. So my question is how do we, as an industry, retain, maintain, develop the human element that we're talking about right now?
I have a great idea. Let's take away everybody that doesn't want to invest in mining cell phones away and see how that works out for a couple hours.
Okay, so Yaman.
I think one thing to consider is something I saw on the front page of the newsletter for the FMF. So there are the typical people you expect to be there, Minister of Energy and Industry and Resources. When we talk about this morning, the Minister of Education is one of the strategic partners for the forum. And we were talking to one another and we said, where does he come in? And then we realized almost instantly the answer to your question is, if you're integrating higher education in these conferences at the planning level, then it can permeate that. But then there's programs like KAICC, Dr. Saeed was speaking about earlier. Those national labs will always need interns. Saudi has thousands of engineers being trained. Maybe that internship, you don't go to the blue chip, JP Morgan, Google, etc., typical track. Come and do research work as one of your internships, even at the freshman or sophomore year, to start planting those ideas for these futuristic industrial companies, whether mining or otherwise. And further that integration between industry and the ministry. Now, obviously, every country manages its education policy differently, but I think those kinds of programs, those kind of sponsorships, maybe even grants for PhD students, so they feel an affinity to want to actually build companies out of their research work, or just bring academia closer to the industry side, because they very much are siloed. People finish their degree and go find a job in mining. You should intervene way earlier, again, even at the very youngest level, because there are all these top engineering schools and chemical engineering programs, for example. And I think that's one way to bring them closer together.
Good.
And maybe to add to that, regarding how to attract talents and how to attract young people, I think, first of all, the mining industry is doing a lot already today to bring up the criticality, like here at FMF, of mining. And therefore, the visibility has risen a lot in order that also the new talents and young people are getting to it. Now, on the other side, there is a lot of activities, and I just pick one of them, attracting talents like women in mining. That might not be for you specifically, but I think this is a great example of how we can attract talents and also support diversity in mining, and where especially also with digitalization, because this is also something I think that is very attractive for young people, that will therefore also, and this is we are supporting as well, where we are attracting young people and talents into the mining industry. Yeah.
Thank you. So I see I'm getting a signal from our taskmaster. And so this is the typical presentation. It starts off slowly, you listen patiently, are there any questions, silence, and then it takes off. Now I see more hands wanting to get things, but we're out of time. So please join me in thanking all of these fantastic panelists.
Thank you.
Yeah.
All right.